Hi everybody, today we're going to talk about absolute value functions. So our basic function is f of x equals the absolute value of x, and think of this as like our parent function or mother function. It kind of depends on what you look at as to what you call it. And I want you to think you can take the absolute value of everything. So the domain for any absolute value function is going to be negative infinity to infinity. Now, the range is going to change. When we're just looking at the absolute value of x, you can see the range goes from 0 to infinity. It's always positive. Of course, we're going to do transformations. So I'm going to move it up, I'm going to move it down, I'm going to flip it over. With those transformations, we will have a different range depending on the function. But I want you to know the domain is never going to change. It's going to always be negative infinity to infinity. So that should make those kind of questions really easy. The transformations we have will be like transformations we've seen with other functions. So f of x equals the absolute value of x plus h means we're going to shift it up h units. F of x equals the absolute value of x then minus h will be a vertical transformation down h units. If we take the absolute value of the quantity x plus h, we're going to move that whole thing to the left by h. If I have the absolute value of the quantity x minus h, then I'm going to be moving everything to the right each unit. So it's basically what we've seen with everything else. So the bigger deal we're going to have to worry about is when f of x is a times the absolute value of x minus h plus k. We'll have a vertex. It'll be at hk. When a is positive, that hk is going to be a minimum. Let me just say, what does that look like? So we have this V kind of shape, and hk is going to be this bottom point. When a is negative, that V is going to flip upside down, so we have a reflection, and then that's going to be a maximum. So we get a lot of information just from knowing if a is positive or negative. So let's run through some problems. Let's say I have f of x is 2 times the absolute value of x minus 3 plus 5. So question A says, does the graph open up or down? So I look at this 2, which is positive, so I know it's going to open up. B says, what's the vertex? Well, that's going to be at 3, 5. So inside the absolute value, I want you to think of going opposite of the sign of the number, and then outside, I want you to keep the sign of the number. Is this vertex a max or a min? 2 is positive, it's opening up, that's a minimum. If you get confused or if you need a quick thing, you can always draw the little V. That shows me that it's opening up, it has a min. The domain, remember I said this will always be the same. That's negative infinity to positive infinity. And then for the range is going to really be helped by the vertex. So if this vertex is at 3, 5, and that's the minimum value, that says the smallest value of the function is 5, so that's part of our range, and it can be bigger than that, so it goes to infinity. Staying with this function, we want to know, is this function going to be narrower or wider than the absolute value of x? So we're still looking at this 2 and think 2 is a stretch. And generally when you think a stretch, you think it gets kind of skinnier, so that's going to be narrower. And then we're going to talk about the horizontal shift. So the horizontal shift is inside the absolute value. It's x minus 3. Sometimes I just think about, well, where is that 0? X minus 3 is 0 at 3. So 3 is on the right. So this is going to go to the right 3 units. And then the vertical shift is outside, and it says plus 5. So that's going to be up 5. Let's try another one. This time I have f of x is negative 1/4 the absolute value of x plus 1 minus 2. A says, does it open up or down? The negative tells me that this is going to go down. Next question says, what's the vertex? The vertex is going to be from the x plus 1 and the minus 2. So I have to go opposite. So the opposite of plus 1 will be negative 1, but I keep the negative 2. Is this a max or a min? Well, if I think about opening down, I know I have this peak right here, which will be a maximum. The domain will still be negative infinity to infinity. And then the range will stop when it gets to negative 2. So this negative 1, negative 2 is the highest point on the graph. So the range is negative infinity, negative 2. Now this time when it says, is it narrower or wider? We want to think this 1/4 is really a shrinking, and a shrinking becomes wider. So this is wider. We think it kind of pushed down. The horizontal shift comes from the plus 1. You know how I say, when is that 0? So x plus 1 is 0. When x is negative 1 is to the left. So this is left 1 unit. And then the vertical shift is the minus 2. So this is down 2. For the next question, f of x is negative 3, absolute value of x plus 4 plus 6. And we're going to start by finding the zeros. So to find the zeros, I'm going to take negative 3, absolute value of x plus 4 plus 6, and set it equal to 0. My first step would be to move that plus 6, so I'll have negative 3, absolute value of x plus 4 equals negative 6. And then I can divide both sides by negative 3. This says the absolute value of x plus 4 is now positive 2. When I take off the absolute value, it's important that I remember that I'm going to have two solutions. So I'm going to have x plus 4 is positive 2, x plus 4 is negative 2. If I subtract 4, I get x equals negative 2, and then in the second equation, x is negative 6. It feels like we're asked the same question twice. What are the zeros? They're negative 2 and negative 6. What are the x-intercepts? They're negative 2, 0, and negative 6, 0. So you do all the work in A, and then you follow through in B. C says, what's the y-intercept? To get the y-intercept, I plug in 0. I have negative 3, absolute value of 0 plus 4, plus 6. This is negative 3 times 4 is negative 12, plus 6 gives me negative 6. It's important we write this as a point, 0, negative 6. Let's look at some graphs to see how we're going to graph these for the homework. So in the homework, you're going to find that there is a tool that shows you different shapes, and this shape, that's a V, is the absolute value. So if it asks you to graph the absolute value, you're going to click on the shape and then go to the vertex. So here's the vertex at 0, 0. Then see how it kind of moves out? You need to give it a second point. So what you want to watch for is what absolute value do you have. Since you just have absolute value, I would click at 1, 1 to get my second point. There are other graphs where it asks you to draw, and it's telling you the kind of transformation you're going to do. This says shifted up 3 and left 4. So I click on the shape, and I think I really want to start at this up 3 and left 4. So up 3 goes to 3, left 4, I'm over at negative 4, and I'm going to put my vertex. Just like the last one, I can see it kind of moves around. So what I think is if I don't have a coefficient, if I don't have some kind of stretching or shrinking, I'm going to go to the right one and up 1, and that gives me my second point. So I know that it's staying that consistent, over 1, up 1. If I do have a coefficient, like this one says negative 2, I'm going to start with the V. I'm going to go to the origin because that's where my vertex is. And to show the negative 2, when I go to the right one, I'm going to go down 2. So that's really what's happening here. This down 2 shows me both the reflection and the stretching. For a bigger graph that says negative 2, absolute value of x minus 2 plus 2, I would start at the vertex. So this vertex would be 2, 2. So here's 2, 2. And then I'm going to use that negative 2 in front to say it's going to open down. And to show the stretch, when I go over 1, I'm going to go down 2 to get my second point. There are lots of questions that accompany the work to say domain and max and min, but I think we covered all of that. What I wanted you to see was the tool, how you're supposed to approach it, and to think about the stretching and shrinking when you go into putting your answer. Good luck.